All right, let's talk about AI. Today, we're diving deep into one of the most important concepts out there right now, Retrieval Augmented Generation, or RAG. We're going to pop the hood, see what's inside, and really understand how this thing actually works from the ground up. Let's get into it.
We often treat AI like it's some kind of magic. But this quote from Literary.eu, which is our guide for today, it just nails it. The truth is, AI isn't magic at all. It's built on stuff we can actually understand, foundational computer science and math. And that's exactly what we're going to do today. We're going to understand it. So, what's the big deal with RAG? Why do we even need it? Well, if you look at a standard large language model, an LLM, it's got a few problems. Its knowledge is stuck in the past. It has a cutoff date. And worse, it can hallucinate, which is just a fancy way of saying it can make stuff up and sound super confident about it. A RAG system fixes this. It connects the LLM to fresh, up-to-date data, grounding its answers in facts we can actually check. It turns a black box into something way more transparent and reliable.
And the solution we're going to tear down today is built with a real hacker spirit. It's this brilliant back-to-basic system made for people who want to know how their tools work, not just, click a button and hope for the best.
So, let me introduce you to PRRS, the PHP Raw RAG system. Yeah, it's a lightweight tool for PHP developers, which is cool. But its real purpose, and the reason we're looking at it, is that it's an absolutely incredible teaching tool. It uses classic, old-school techniques to show us precisely how RAG operates under the hood.
The key word here is pedagogy, which really just means teaching. See, instead of using some fancy, complex AI library where everything is hidden, PRS is built from scratch. It makes us look directly at the raw math, the actual mechanics. And honestly, that is the best way to demystify what's really going on inside that AI black box.
Okay, let's start taking this thing apart. Part 1 of any RAG system is its brain, its knowledge base. And for that, you need an index. We're going to see how PRRS uses a classic technique called TF-IDF to turn a bunch of documents into a searchable mathematical map.
Now, before you can do any math, you got to prep the text, right? It's like cooking. First, you clean it all up. Get rid of common words like the, and is. Then, you chop up the big documents into smaller, bite-sized chunks. And finally, here's the crucial part. You vectorize them. You turn those chunks of text into lists of numbers, vectors, that a computer can actually work with.
So how do we turn words into numbers? Well, it starts with something super simple, term frequency, or TF. This is really intuitive. It's just a score for how often a word shows up in one specific chunk of text. If the word vector pops up 5 times in a 100-word chunk, its TF is just 5 divided by 100, so 0.05. It's that easy. It's just a measure of how important a word is right here, in this one spot.
But here's where it gets really clever. Inverse document frequency, or IDF. This step measures how important a word is globally across your entire library by checking how rare it is. Think about it. A word like system is going to be everywhere, so it's not very special. It gets a low IDF score. But a specific term, maybe a technical one, that's going to be rare. It gets a high IDF score, telling us it's probably pretty important.
And then, you just put it all together. You multiply the term frequency by the inverse document frequency. Boom! You get the TF-IDF score. This one number tells you how important a word is in a specific document compared to all the other documents. A high score means the word is common right here, but rare everywhere else, which basically means you found a fantastic keyword.
Okay, quick recap. We've turned all our text into these mathematical vectors using TF-IDF scores. So now we've got a library of numbers. The big question is, when a user asks a question, which we also turn into a vector, how do we find the best match in our library?
The answer is this really elegant idea from linear algebra called cosine similarity. Now, don't let that name scare you off. The source article has the perfect way to think about it: angular proximity. We're not measuring the distance between two vectors, we're measuring the angle between them. Basically, are they pointing in the same direction?
Let's just picture it. Imagine your question vector and a document vector are like 2 arrows pointing in the exact same direction. The angle between them is 0. That gives you a cosine similarity score of 1. It's a perfect match. They are talking about the same thing.
And of course, the opposite is true. If two vectors are at a 90-degree angle to each other, if they're totally perpendicular, then they have basically nothing in common, conceptually speaking. They're pointing in completely different directions. So their similarity score is 0. No match here. So we've taken apart the two big engines here, TF-IDF for making the vectors and cosine similarity for comparing them. Now let's put all the pieces back together and watch this system actually work.
And here it is, the whole process live. First, you ask a question. Instantly, it gets turned into a TF-ID vector. Second, the system uses cosine similarity to compare your question's vector against every single chunk in its library, checking all the angles. Third, it grabs the chunks with the highest similarity scores, the ones pointing in the same direction. And finally, it stuffs those relevant chunks right into the prompt it sends to the LLM, giving it the context it needs to give a great answer. That right there, that is retrieval augmented generation.
So the big takeaway here isn't just about how PRS works. It's about why this whole approach is so important. We're moving away from just using a tool to actually understanding the fundamental ideas that make it tick.
I love this quote from the source article because it just gets to the heart of it. We live in this world where everyone says, oh, just plug in an API. Don't worry about how it works. Projects like this are the antidote to that. They stand for a deeper, real understanding of the technology we're all starting to depend on.
Now let's be really clear. The point here is not that this simple TF-IDF method is better than the super advanced systems that use neural embeddings and all that. It's not. But its value as a learning tool is just massive. When you understand these fundamentals, you are so much better equipped to understand and even to debug the more complicated systems you use every single day.
So, we'll leave you with this question to think about. The next time you use an AI tool, any AI tool, ask yourself, do I really get what's happening behind the curtain? Because as we saw today, it's not some unknowable magic. It's just math and logic. And understanding that, well, that's the real key. Thanks for joining us.